Hello, friends, and welcome to PWN Physics 365, a podcast dedicated to keeping you in the zone 365 days a year. This day in physics, word of the day, killer resource. Buckle up because here we go. Well, all right, friends, hello and welcome to Physics 365. So I think we know the drill by now. Let's dig right in. On this day in physics, 16th of January 2003. Space Shuttle Columbia takes off on its would-be final 28th mission, during which the space shuttle broke apart during re-entry. To all those who perished on the mission, PWN Physics 365 remembers and salutes you. So, that's what happened in our physics past. Let's take a look at the word of the day, friction. Friction is a resistive force in nature which opposes motion. There are several causes for this. Examples of this are dry friction, fluid friction, kinetic friction, static friction, lubricated friction, internal friction, etc. There are many different types of friction. I think you get the idea. From Wikipedia, when surfaces in contact move relative to each other, the friction between the two surfaces converts kinetic energy into thermal energy, aka converts work to heat. This process can have dramatic consequences, illustrated by the use of friction created by rubbing pieces of wood together to start a fire. So yeah, friction can do a great many things. Let's go a little deeper here. In the case of the Columbia incident, the space shuttle re-enters the atmosphere with such speed that particles begin to crash into the space shuttle. They collide with such force that vast amounts of thermal energy are created. The wing was damaged, and the heat was able to make its way into the wings and damage them, causing the space shuttle to disintegrate in the atmosphere. Friction is a very powerful force which has a great variety of uses. Without friction, you wouldn't be able to drive your car, for instance. The tires on the car allow your car to move because of friction with the road. If you've ever been on an ice skid before, you can appreciate why friction can be useful. The friction between your brake pads and your rotors or brake drums are what causes your car to stop. Friction between your feet or shoes or sandals is what allows you to walk around. In fact, almost all animals rely on friction in one way or another to move around. In physics, we categorize how resistive objects are with what is known as a coefficient of friction. Sandpaper has a much higher coefficient of friction than, say, ice. Sandpaper will oppose motion much more and generate a great deal of heat, whereas ice will not facilitate motion, but rather oppose motion much less and generate much less thermal energy in the process. So yeah, it's not that ice, makes you slip. What it does is it doesn't oppose your motion, and so that's, what makes ice so slippery per se, because once you're moving, it's going to not oppose you and allow you to continue moving forward, as much as you want in some sense. So that's friction, a little taste of friction. So today our killer resource is A World Without Friction. And what that is an awesome video from MIT which describes what your world might be like without friction and gives you an appreciation for how much of a role friction plays in your everyday life. So yeah, try to tie the word of the day, the history, and the future all together in one thing. So do head over to the blog, pwnphysics.blogspot.com, to check it out. And that's the word of the day for today, Saturday, January 16, 2016. And I will see you guys tomorrow with another edition. So until then, stay in the zone, and I'll see you tomorrow, guys. Take care.